Students, we've spoken about dispersion, how data is dispersed. So for example, the range. The range describes dispersion. So let's talk about test grades. So a teacher is analyzing test grades for her students. And let's say the range was 80 points. The range was 80 points. That's a pretty wide dispersion, right? If the maximum grade, let's say, were a 95, that would mean that the minimum grade was a 15. Ugh. Right, so dispersion describes how data is spread out, the spread of data. There is another measure of dispersion. This measure is called standard deviation. Standard deviation. And to deviate means to go against. And this is very similar to what standard deviation is. It is the spread from the mean. So the standard deviation helps us understand if you have a mean, so if you average your numbers together, how spread out is your data relative to that average, to that mean. So let's look at another example of some tests. Let's say that the teacher had an average of a 78%. So the mean was a 78%. And then let's also suppose that the standard deviation was 5 points. So 5% is the standard deviation. Well, what this means is that the data on either side of 78, so 78 minus 5 is 73, and then 78 plus 5 is 83, so from 73% to 83%, to 83%, that would be one standard deviation. Because we've got one standard deviation below the mean and one standard deviation above the mean. So we add and subtract the standard deviation from the mean to determine what one standard deviation away from the mean is. So from 73% to 83%, there will be a majority of the actual students' test grades. Now let's think about this for a second. In this particular example, does a teacher want a higher standard deviation or a lower standard deviation? Well, to test it, let's try each out. Let's say that the standard deviation were higher, that it were double. The standard deviation, instead of being 5% for this particular test, let's say that the standard deviation were 10%. So in order to find one standard deviation, we would subtract 10% from the mean, and we would add 10% to the mean. So 68% to 88% would be one standard deviation. In this case, the data is more spread out. The higher the standard deviation, the more spread out the data is. And if you're a teacher, I'm not sure that you really want a higher standard deviation. Because think about it. When the standard deviation was lower, a majority of the students were passing. Now that the standard deviation is higher, true, some students are performing better, but some students are performing below passing level of 70%. Let's see if the standard deviation were lower, what this data would look like. Instead of 10%, let's say that for this particular set of tests, the standard deviation was 1%. Now the standard deviation is tiny. It is minuscule. We will add and subtract 1% from the mean in order to find one standard deviation. So one standard deviation above and below the mean would be 77% to 79%. Be one standard deviation above and below the mean. Now, a majority of the students are in a very tight range. Instead of the data being very spread out, this data is very compact. Now, in this case, a majority of the students scored between a 77 and a 79. Now, as a teacher, that is particularly helpful information because you can diagnose, well, 79, yeah, that's passing, but what if we could move the mean higher? And you'd be able to analyze, maybe I could teach something a different way. Maybe the students were absent and maybe I needed to hold more tutorials. But either way, when the standard deviation is smaller, you have, in this particular example, a better idea of how to diagnose some problems. But the main message here for standard deviation is that standard deviation describes dispersion, the spread from the mean. And one standard deviation above and below the mean will give you a majority of your data. Thank you very much, and have a great day.